If one looks at these lines under high magnification, one can see that actually there are two distinct line types. The longer lines which are continuous and fluid have a distinct furrowed profile. With the artwork placed underneath this dome, 40 individual digital images are taken of the same surface detail as it appears under different angles of illumination. It was not easy to decide what aspects of my work to discuss with you this evening in the short time we have. But after weighing different options, I decided to focus on two technical aspects. There we go. First, I want to explain how the black and red colors on these vases were produced. It is a brilliant technique that remained a mystery until modern times. Then I'll discuss a decorative feature called the relief line that was first used in the red figure technique. This enigmatic line that stands proud of the surface of red figure vases was the subject matter of much discussion and disagreement among scholars and specialists in the field for many decades. And there was no consensus among them regarding the tool and application method used by the ancient Greek potters to produce it. This line became the central focus of a research project conducted here at the Worcester Art Museum at the Conservation Department, and we believe that we came to the bottom of the mystery. So let's start with how the characteristic black and red colors on Greek vases were produced. As Amanda already said, on black figure vases, the figures are black on a red clay ground, while on red figure vases, the decorative process is inverted. The figures are red and the background is black. The black portions on the vases are the painted parts. The shiny black paint is called gloss. It is not really a paint, but a dilute clay that has a high content of silica and potassium. Both these components, silica and potassium, are prime ingredients in glass making. This is very important, and we'll come back to this later. The unpainted parts of the pots reveal the natural orangey red color of the fired clay body, just like a terracotta flower pot is red, because the clay it is made of is red. Greek pots underwent a complex firing process that ultimately resulted in the distinctive black and red colors. The firing of these pots took place in three phases. First, under oxidizing conditions, then under reducing conditions, and then again under oxidizing conditions. But no worries, I'll describe each of these steps more in detail. The clay that the ancient potters used to make and paint their pots was rich in iron. And it was the color of the iron corrosion molecules in the clay that rendered it the black and red colors. Doesn't iron rust or iron corrosion come in different colors? It can be black, like this cast iron skillet, or it can be red, like this rusted mailbox. Well, the Greek potters figured out through empirical observation and through trial and error that under certain atmospheric conditions within the kiln, the clay turns black, and under other conditions, it turns red. So they used this natural phenomenon to their advantage when they fired their pots. On the right is a modern replica of an ancient kiln that was constructed for a hands-on class at Johns Hopkins University in 2015, when the professor-student potter team recreated Greek pots using ancient techniques, including the three-phase firing process, which I will describe next. So once the painted pot had dried, it was placed in the kiln and fired using dry wood as fuel. The vent on the top of the kiln was kept open to allow oxygen to enter the kiln. This created an oxidizing environment rich in oxygen, which converted the iron molecules of the clay body and the painted decorations to red ferric oxide. If the pot had been taken out of the kiln at this point, its color would have been entirely red, both the body of the pot and the painted portions. Here you can see in the sketch on the right that you can see that our black figure neck amphora is in there. This is a pretend sketch that our wonderful pre-program intern sketched for us for this purpose. And it's of course the black figure amphora with the Heracles scenes. So in the second phase of the firing sequence, the kiln master placed green wood on the fire and closed the vents, thereby cutting off oxygen from the kiln and creating a reducing or oxygen-poor environment, which converted the red ferric oxide molecules of the body and the painted decorations to black ferrous oxide molecules. If the pot had been taken out of the kiln at this point, the entire pot would have been black, as you can see on the sketch on the right. Remember I mentioned earlier that the silica and potassium in the gloss are key components of glassmaking? Well, now the heat in the kiln was raised even higher to the temperature at which the painted decorations made with gloss slightly melted into a glassy substance. Because of these two components, the technical term for this phenomenon is sintering. In the third phase, the reoxidation phase, the kiln was cooled somewhat and the vents were opened again, allowing oxygen to re-enter the kiln. The oxygen turned the black parts of the vase body red again, but the painted parts remained black because the oxygen could not reach the iron oxide molecules within the painted portions, because they were now trapped within the glassy matrix. Once the kiln had cooled, the finished vase was removed, and it now displayed the design in the black and red colors. This method used to produce the distinctive red and black colors of Greek Attic vases is one of the milestones in the history of ceramic technology. It is remarkable that modern potters were not able to reproduce it in modern times until the German chemist Theodor Schumann finally figured it out only in 1942. The next part of my presentation tonight is our study of the relief line, first introduced in the red figure technique in Greek vase painting. The fine black lines you see in this detail of the snake slithering up the leg of Peleus and the folds in the fabric of his garment on the stamnos, on our stamnos in the exhibition, are all examples of this relief line. The red figure technique gradually replaced the earlier black figure technique around 500 BC, because the painters could now render details within the red figures using brushes. In black figure painting, they had incised the lines within the black figure portions with gravers, an action that created uneven and somewhat awkward lines, as one can observe on the left here. I think it is pretty clear. They're kind of awkward. Using the shiny black gloss, the figure depictions on red figure vases became more realistic and more dynamic, and the representations of anatomy and garments were more naturalistic on the red figure pots. Even gestures and emotions could be conveyed better. All the fine lines you see on the stamnos detail on the right here are also relief lines. Why is this line called relief line? As the word implies, the relief line is made of very thick black gloss and stands proud of the surface. The Greek vase painter used the relief line to outline the figures, as you can see in the detail of the head of Thetis on the right. And once the outline was placed, the artist painted in the details, like eyes, lips, ears, nostrils. Here, Thetis's curly hair is even painted in relief, with relief dots. And below is a detail of the snake again. And all the fine lines on it are painted relief lines. I also want to show you two beautiful examples of red figure vases by the Berlin painter that I recently saw at a major exhibition of this painter's work at the Princeton University Art Museum. These two vases very prominently feature the relief line decoration. One vase belongs to the Met, the one on the top, and the other to the British Museum. I became fascinated by this unsolved mystery of what tool and application method the ancient painters used to produce this relief line during my graduate school years. And I was determined to tackle it when the time was right. And a few years ago, the right time came. And in collaboration with my late colleague, conservation scientist and painting conservator Philip Klausmeier, the relief line study became the central focus of a research project here at WAM's Conservation Department. If one looks at these lines under high magnification, one can see that actually there are two distinct line types. The longer lines which are continuous and fluid have a distinct furrowed profile. So right here, these lines. While the shorter lines, which are less fluid and often have a turn in the line, are especially thick and high and have a profile with a single peaked ridge. See here? In order to better understand what tools created these distinctive lines, it was essential to first characterize them. This was done with the help of two instruments which had not been used to study Greek ancient vases, before. The reflectance transformation imaging instrument, or the RTI, mounted on an adjustable stand and connected to a computer, consists of a dome-like structure with 40 lights fixed to the inside and a high-resolution digital camera at the apex. We have this instrument in our conservation department. With the artwork placed underneath this dome, 40 individual digital images are taken of the same surface detail as it appears under different angles of illumination, one picture at a time, as each of the 40 lights turns on and off once. The 40 images are then combined into one file with computer software. Here we have an image generated through RTI showing us how much topographical and surface information one can gain from this technique. Or this one on the left. A photo taken under normal light conditions, like the one on the right here, just cannot capture the surface topography as well as the RTI can. The second instrument of our study was an ultra-high resolution 3D laser scanning confocal microscope that belongs to the Worcester Polytechnic Institute. Here is Philip Klausmeier operating it. On the stage is the stumnose fragment of Thetis's head. It was imaged while the vase was disassembled during conservation treatment. Here we are in the midst of examining the eye of Thetis, which you can see on the screen that Phil is looking at. This microscope can produce real color 3D images as well as 3D elevation maps, like these ones on the screen, showing the relief lines making up the eye of Thetis. These relief lines are the ones with a single peaked ridge. While these here, from Thetis' shoulder, have the distinctly furrowed profile. Once we acquainted ourselves with the anatomy of the relief lines, I prepared mock-ups using different tools to try to reproduce these lines, which in turn we also examined with our two instruments. Among the tools that have been suggested to produce the relief lines by specialists in the field of Greek vases are a reed or quill pen, a thin brush, a brush with just one or a couple of hairs, and an instrument for extruding the glaze, very much like a baker extrudes icing when decorating a cake. Greeks at the time of Attic ware production were familiar with the syringe as a medical instrument, which was constructed from a quill and an animal bladder. It must have looked somehow like the implement we have here on the right. There is a general consensus that a reed or quill pen could not have produced these relief lines because the thick gloss material could not have traveled through the very narrow pen channel, like ink can through the capillary action effect, because ink is so fluid. Instead of an animal bladder, I constructed a tube with a goose feather quill tip and filled it with a slightly dilute commercial spackling compound, which I extruded onto a surface. This method could indeed produce very thin lines, but they had a smooth surface and not the furrowed or ridged profile of the ancient lines. Also, a blob of medium formed at the beginning of each line, which could not be observed on the ancient lines. This confirmed that the relief lines were definitely not extruded. Then I experimented with a range of fine conventional sable brushes using a clay bowl manufactured for gilding frames. At the necessary consistency to make a three-dimensional line, the clay bowl did not flow or easily transfer from the brush to the paint substrate. And when diluted to make it more fluid, the line lacked the unique relief quality that we were looking for. Also, it was not possible to create a line with a sharp turn in it. The brush hair would flick out when making a turn in the line, leaving a muddy mess, as you can see here. Then I constructed a variety of brushes made with one or very few hairs of different lengths and thicknesses, using horse tail hair, horse mane hair, pig bristles, cat whiskers, and human hair. This brush type was suggested as a possible tool for producing the ancient relief lines by a Swiss archaeologist named Gerhard Zeiterle in the 1970s. Here is such a brush made with 3 horse mane hairs, dipped in the gilder's clay medium. According to Zeiterle, the relief line was produced by dipping the brush into the glaze, laying it down, and lifting it straight up. The distinctive ridge in the middle of the lines is created by the action of lifting away the brush hair. We named this line laid relief line, or simply laid line. The laid line technique can be observed in this real color confocal image of Thetis's eye that we saw earlier. And here is the corresponding 3D elevation map. One can also make loop-shaped lines with the laid line technique, as I'm doing here. The peaked ridge is clearly visible. The lines like these are visible in the headdress of Thetis here on the top, on the Worcester stumnose. And here, for comparison reasons, are 2 confocal microscope images of an ancient and a modern loop. We found that this technique only produces lines with ridges and not the second line type that we had observed also, the lines characterized by a furrow running through the middle. We were, however, able to replicate these lines by setting down the tip of our brush, as you can see here, and pulling it across the surface. The action of the brush hair as it is pulled through the clay bowl across the surface produces the characteristic furrow. Unlike the laid lines, these lines can be longer than the length of the brush hair. We gave this line type the name pulled relief line or simply pulled line. I want to add that in our experiments we determined that the brush with a single hair could not have produced any of these lines because a brush of just one hair does not pick up enough medium to produce a line. 2 or more brush hairs are needed to physically pick up enough paint medium through the capillary action phenomenon to produce a line. When we examined the modern and ancient pulled lines with our 3D microscope, the resemblance between these lines were striking. The ancient ones and the modern ones. To our knowledge, no tools used for decorating vases in antiquity have survived. But at the Museum of Fine Arts, there is a fragmentary drinking cup that depicts an artist seated on a chair holding a cup in his left hand and a tool in his right one. He is clearly engaged in a very delicate task, underscored by the way that his pinky is about to steady his hand on the vessel. When examined under magnification with raking light, a single relief line connecting the tool and the surface of the vessel is discernible. This tool can quite convincingly be identified as a brush of the type I constructed. Here we have a depiction of a brush that was used to paint relief lines, painted with the relief line technique. Isn't that cool? In addition, one can observe that the painter is holding the cup's stem between his left pinky and ring finger, and with his left thumb and index finger, he's carefully holding what appears to be a reservoir for the gloss close at hand. Because the consistency of the gloss for the relief lines had to be thick without being too dry, the painter could only use a small batch of it before it would dry out and become unusable. Amanda tells me that this reminds her of the last steps of modern dental cleaning. When the hygienist polishes the teeth with the gentle abrasive that comes out of a little container, right, that she dips her brush into as she goes from tooth to tooth one last time. In conclusion, I want to say that we now feel quite confident that the ancient Athenian vase painters used brushes of just a few hairs to paint the relief line, and they applied the gloss in the manner described, producing 2 types of relief lines, the laid and the pulled relief lines. We have had the opportunity to present our research at several conferences and symposia, the modern kind of symposia, and have also been invited to publish it. We are quite proud that it has gotten the attention of specialists in the field of Greek vases, who are finding our results convincing. This brings me to the end of our presentation. We hope that it has helped you contextualize the 3 vases on display in the Jeppson Idea Lab and appreciate how these accomplished artists decorated them about 2,500 years ago. We want to invite you to visit the Idea Lab to see these masterpieces. Watch the video and explore the comprehensive content of the iPads, which touch on many aspects of Greek vases that we could not cover this evening, such as the conservation of each vase and the discoveries made during conservation, the archaeological excavation of Greek pots, the history of collecting vases, and the sad reality of the looting and illegal trading in antiquities. Before we open the floor to questions, I'd just like to say what a wonderful collaboration this project has been. The scientific research and technical study of these vases would not have been possible without Philipp Klausmeier. This project was one of his last major research projects before he passed away last year. We are also extremely grateful to Professor Chris Brown from WPI for letting us use their 3D laser microscope. Working with Amanda has been a huge honor. Her moving to Worcester with her family last summer was incredibly timely. And can you believe it? She gave birth to a beautiful son only 4 days ago. And finally, a huge thank you goes to Pagano Media for producing the video in the gallery, and to the Worcester Art Museum's entire exhibition team. Thank you for your attention. So we'd like to open the floor to some questions, if there are questions. Yes?
Thank you so much for a wonderfully informative presentation. I've been teaching here at the Worcester Art Museum for about 40 years, and doing oxidation, reduction, and reoxidation has always been very challenging when, it's not paint, it's literally a chemical reaction. But can you clarify that the slip that they're painting with, the color of that, though, isn't it the color of the material?
Yeah, clay.
So it's red. They're painting on a red substance. The slip is red, and they have to visualize what it will look like in black. That's correct?
Mm-hmm.
So when they're creating that, how do they create the slip?
Right.
When they're working
So we believe that they probably added to the slip that precisely was the same color as the other clay of the pot body, right? And they must have added like an organic colorant. Like we would use food color, for example, just so that it was clear what was painted decoration and what was not. And then that would disappear, would burn off in the kiln.
All right, thank you.
Yeah, excellent question.
It's confusing for people to understand, and I said, yeah, this is it.
Yeah.
Yeah, you're right, it's confusing, but that's very helpful.
That's why, yeah.
Coloring, thank you.
Like a food coloring, yeah.
Thank you. What was the white?
So the white, right, I also said, or you said, it's a clay. You can probably answer the question yourself. It was pure white clay. It did not have iron in it. Oh, it's really very basic. It just makes a lot of sense. White clay, the white decoration remains white because there's no iron in it. More? Any other questions? Yeah.
So I assume with the red figure, you would lay down the relief line and then you would paint the black space behind it. Do we know what kind of brushes they might have used for that?
Yeah, so they probably used broader brushes. Like, I think we even have some pictures here. Yeah, like just broad brushes. While for the relief line was like just one. Let's see, here we go, like here. So broad brushes like that. Or that.
So you mentioned that you took the pots apart. Can you talk a little bit about that? It sounds like a scary thing to do.
Yeah, so before we set our hands on, all these objects are unique art pieces. And so we have to be sure that whatever we do, we don't make a mistake. So before we put our hands on the pot, we familiarize ourselves with the restoration materials. Like old adhesives, in this case, to take them apart, you have to know what adhesive was used to put them together and what would reverse an adhesive like that, meaning what kind of solvent you would want to use. In this case, we dealt with two kinds of adhesives. old adhesive. And when I say old, it means adhesives that were used in the 19th century, most likely. And those would have been animal glues, like hide glues, or shellac. Those are usually the typical adhesives that you find. So knowing that, we were able to tackle that problem. Not problem, but the reversing it. And so we know that shellac softens we place the object in a vapor chamber, because the vapor of a solvent mixture consisting of acetone and ethanol softens the shellac. It doesn't dissolve it, it softens it. So when you go back to the solvent chamber, which basically it's a plastic bag, you have the object in a dish, in a low dish, and then put the plastic bag over it and tie it up. And then you have a little jar with the mixture of solvents that I just mentioned. And after 2 days or so, the vase is kind of collapsed onto itself. And you know that that's going to happen. So you stuff it with cotton wool, with rags, so that supports the weight of the vessel collapsing onto itself. And then you take out each piece one at a time and scrape off the edges, and so on. And you can see a lot of that in the Idea Lab iPad, the whole process. I mean, each vase was unique, had its own problems, or its own issues, I should say. And so once you remove all the restoration materials, then you go and use modern materials to do the restoration. And with the materials we use nowadays, they are not the materials that I just mentioned. Nowadays we have synthetics and acrylics, and they're readily reversible, easier to reverse if needed. Check out the iPad. Lots of photos too of the sequence of the conservation steps that we took.
And the video too.
And the video
shows the whole lack of those being conserved. Yeah.
I had a question, maybe more for you, Amanda. You were sort of making a distinction between the everyday wear and then the more decorative objects, and sort of still saying that they were considered craftspeople. I was just wondering what the relationship was like between the patrons and the artists, whether they would have been commissioned works, these sort of more decorative pots, or whether it would have been something that, like, who kind of came up with what image was going to go on them? Do we know that at all?
If only we knew. But we do have some objects with inscriptions that were painted on pre-firing, which suggests that they were bespoke pieces. So there's this really wonderful example where a vase painter wrote on it, I can't remember the names, forgive me, but so-and-so made this vase for so-and-so, and then so-and-so gave this vase to so-and-so, and this Athenian vase painter actually used a Sicyonian dialect, a dialect from a community farther to the south, to make the inscription of the dedication. So you almost wonder if he was even kind of catering to a foreign audience. But and sometimes we have images that just seem so unusual that we wonder, well, are they naming a certain person in a label on the vase? Like, it's an unusual name, an unusual occupation. Was this commissioned by a family maybe, and shows one of their patrons bringing olive oil to the goddess or something like that. Yeah, so we have these tantalizing clues, but the answer is we really don't know for sure how the process worked, but it's a great question. Yeah.
One more question. I'm getting signs from back there. Yeah, you. Yeah.
I just raised a question because I'm not really that familiar with the kiln, and my question is for the dark clay figures on red. Are we talking about a different type of clay, or is it a brush dipping into a different type of clay to oxidize the figure when it's being put in the kiln? And then after that, is there more detailed work that has to go in? Is it, I guess the steps of the creating it, I'm not very clear on.
I think the key to the gloss
Yeah.
are those two components that are used for glass making. I think that is what is the key to
So it's
turn it
not-
into
Right.
the final product we find.
Okay.
That it really comes, and the glossiness of it, right? It's very glassy. That's also because of that.
Thank you.
So, no.
Thank you so much.
Oh, hey, oh, you're welcome.